Find the sum of the following series. You have the summation of 1 divided by n times n plus 3, and start from 1, goes to infinity. Well, first of all, we need to use partial fractions. Partial fractions to make sure we get a simpler version of the general term. 1 divided by n times n plus 3 can be written as a divided by n plus b over n plus 3. So if you take common denominator on the left-hand side, your common denominator is n times n plus 3. You end up with a times n plus 3 plus b times n, and the numerator on the other side is equal to 1. So if you set n equals to -3, -3b becomes 1, so your b is -1/3. When n is equal to 0, what do you get? You get a times 3 equals to 1. Or a is 1/3. Very good. So your series can be broken down into the summation of 1/3 divided by n plus -1/3 divided by n plus 3. And n starts from 1, goes to infinity. Well, what you can do, you can basically factor out 1/3 if it's easier for you to see it that way, and write it as 1/3 times the summation of 1 over n minus 1 over n plus 3, and start from 1, goes to infinity. Let us plug in n equals to 1, n equals to 2, n equals to 3, and expand this series. Expand this series, because we want to see what is the behavior of this series at this point. Here you have 1 over 3. And if you plug in 1, when n is equal to 1, what do you get? You get 1 divided by 1 minus 1 divided by 4. When n is equal to 2, you get 1/2 minus 1 over 5. When n is equal to 3, what do you get? You get 1/3 minus 1 over 6. If you plug in 4, for example, what do we get? If n is equal to 4, you get 1 over 4 minus 1 over 7. Okay, I'm getting a pattern here, am I right? When n is equal to 5, I get 1 over 5 minus 1 over 8, plus the rest of the terms, right? And this guy is 1 over. You can write I, you can write k as well to get the partial sum. 1 over k minus 1 over k plus 3. And then you find the limit of this partial sum. So let's call it S sub k. So S sub k is equal to 1 over 3. But here I can cancel out some of the terms in between. Which ones, for example? Here you have, for example, you get 1 over 5, negative 1 over 5. Then you have 1 over 4, negative 1 over 4. And if you continue this process, you can see you can get rid of a lot of terms here, right? Except for what's left. You get 1, and here you have plus 1/2 Then you have plus a third. So it seems like the smallest value that gets canceled out is 1 over 4. And then you get 1 over 5 that get canceled out. And then the rest of the terms, if you continue this process, you can continue canceling this. This term, 1 over k, also gets canceled out with the previous term, right? But let us take a look at this. The terms that are left are negative 1 over k plus 1 minus 1 over k plus 2 minus 1 over k plus 3. Now, if you take the limit of s sub k as k goes to infinity, this is equal to the limit of a third times 1 plus a half plus a third minus 1 over k plus 1 minus 1 over k plus 2 minus 1 over k plus 3 as k goes to infinity. But when k goes to infinity, this term is basically 0. This guy is also 0. This guy is also 0. So you're left with a third multiplied by, if you take common denominator, 6. Here you have 6 plus 3 plus 2, or you get 11 over 18. So your telescoping series is convergent to 11 over 18. So let us summarize what we did. Here you have the summation of 1 divided by n times n plus 3. I didn't ask you to check the convergence and divergence of this series. I asked you to find the sum. If I add these numbers together, if I add these fractions together, where does it go? What does it approaching to? First, we use the partial fractions to break it off into smaller pieces. You end up with 2 fractions, a third over n plus negative a third over n plus 3. I factored out a third and wrote it in front of the summation of 1 over n minus 1 over n plus 3. It is similar to a telescoping series. So what I did, I started expanding the series, see what do I get for the partial sum. S sub k, which is the partial sum, is a third. When I plug in 1, I get 1 minus a fourth. When I plug in 2, I get a half minus a fifth. When I plug in 3, I get a third minus a sixth. When I plug in 4, I get 1 4 minus 1 over 7. When I plug in 5, I get 1 over 5 minus 1 over 8 plus the rest of the terms. You can continue this process and add more terms here and before it. So I end up canceling some of the terms like negative a fourth and a fourth, a fifth, negative a fifth, and so on. All these terms, they get canceled out except for 1, a half, you can see them here, 1, a half, a third, and also negative 1 over k plus 1, negative 1 over k plus 2, negative 1 over k plus 3. Now, if I take the limit of the partial sum, the limit of the partial sum is 11 over 8. So the telescoping series is convergent to 11 over 8. So common mistake on the exam. Common mistake. Student write, since the limit of 1 divided by n times n plus 3 as n goes to infinity is equal to 0, so our series is convergent to 0. This is wrong, everybody. This is just a limit of the general term. For the series, you need to find a sum to say that it's convergent to that value. You need to basically do all of these steps to find the sum of this telescoping series.